So we've been dealing with logarithms for a while now. They are inverses of exponents. Now we already know that. But today on this section 7.5, we're learning about the properties of logarithms. We actually have these memorized. The product property, the quotient property, the power property. So you had this half sheet of paper as notes. Product means what? Multiplication. So that's exactly what we have here. We have log base something of m times n. And the product property allows us to expand or condense. When you have multiplication of that single log of that single of this two terms, you could take that single log and split it into two of those same logs with the m and the n right here with the plus sign in between them. That's called expanding. Or you could go backwards where you have log base b of something plus that same log base b of something else. And you could take those two separate logs and you could put them back together as that one log and multiply the m times n together. I know that sounds really weird. Quotient property, quotient means divide. So if you have log of something divided by something, so since quotient means divide, that's when you have a log of something divided by something else. And you'll be able to expand it where you take that single log and you split it into two logs where you have log of this top one minus that same log of the bottom one. Again, yeah, I know this is weird, especially because it's a bunch of letters. Power property, power is an exponent. And what you could do whenever you have an exponent right here, you could have log base anything of something to any power, and that power you could actually bring it down and put it as multiplication of whatever value that was. So whatever, if you have a power of 5 out here, you could put a times 5. Power of 2, you could put a times 2. And that's called expanding with the power property. So we need to have these three properties memorized. There's no way around it. We have to have them memorized. Okay? I had you copy this down from the board, and right here, it's with numbers instead of letters. It might help you out memorize a little bit easier. You have log base 3 of something times something. So you're going to split that single log base 3 into two log base 3s. And you're going to have a plus sign between them. And it'll be log base 3 of that first plus log base 3 of that second. So you have log base 3 of 5 times log base 3 of x. Likewise, that's called expanding. Likewise, I could just give you that right there and tell you to condense this. Well, because you have one single log base 3 and one single log base 3, they're the same thing. You could write them as one single log base 3. I probably shouldn't have said single. You have a log base 3 here, a log base 3 there. You could write them as one single log base 3. You could condense it to one single log base 3, but you have to multiply these guys together. Likewise, if you have log base 3 and log base 3, same exact log, and you're subtracting, then you know you could be using the quotient property. And quotient property is really division. So you could write these two separate log base 3s as one single log base 3, and it's always going to be the first one divided by the second one, so 5 divided by x. And the power property is probably the easiest of them all, because if you ever have a power, you could write that power out here in the front as multiplication. Or backwards, if you had 5 times log base 3 of x, you could take that multiplication of 5 and bring it back up to become the power. So the properties are used to expand or to condense, right? And in reality, we're going to be using these condensing skills with these properties to be able to solve equations from our homework. Let's check out the homework. This was the worksheet, right? 7.5 WSPM. Notice that I start number 11. The worksheet, if you look at the solutions, yeah, it has 1 through 10, but it has some questions that I don't believe are going to be asked on the midterm, so I just decided to skip them, right? You could always try them if you want, but let's take a look at number 11. Now, before, we've already solved logarithmic equations before. If you wanted to get rid of a log, you would raise it to be the power of the base of your choice to get rid of that log. Now, normally you say, oh, log base 10, I'm going to raise this whole thing to be the power of base 10. And yes, that's what you want to do. But you can't do that to this side yet, because right here you have 3 times log base 10. It's not just a log base 10. Does that make sense? I need it to be just a log base 10, not with the multiplication of 3 out in the front. So right here, what property am I going to use to condense?
Power.
Power property. Power property allows you to take this multiplication of 3 and to write it as an exponent on the x, as a power on the x. So let's rewrite this equation. We have common log 27 equals common log x to the third. Now, you know what, guys? I do want to warn you. I see students when they're doing this work, that if they write this base too big, you're gonna get some points deducted on your answers. If you write this 10 as a base, it better be small. It better be towards the bottom. If it's an exponent, it better be small. It better be up towards the top. Some people put a 3 right here and say, oh yeah, that's the exponent. That looks like an x times 3 if you write it big. So make sure that you write it small. Use the appropriate notation or appropriate size on your notation. Anyhow, we now have common log on both sides. We can now get rid of those common logs by raising them to become powers of base 10. So yes, 10 to the log base 10 eliminates. 10 to the log base 10 eliminates. So what's my new equation? 27 equals x to the third. I need to get rid of that x cubed. I want to solve, right? I want to get x by itself. So to get rid of an x cubed, you're going to apply the inverse of a power of 3, which is the root of 3. So you're going to apply a third root to both sides of your equation. Then you'll get 3 equals x as your final answer. X equals 3. So on all these equations, we're going to be using these properties. You have to have them memorized to be able to expand or condense. Well, mainly condense when we're solving, unless they ask you to expand. Let's do the odd ones on this video. So what property am I going to use on number 13? I see a plus sign here. The only property involving a plus sign in between the two logarithms is the product property. Now what does the product property say? That if you have log base 4 of anything plus that same log base 4 of something else, you could condense it and make it one single log base 4 of, and whenever I condense, I use parentheses when I multiply this times this. So I might as well just write it as 5x. I mean, you could put 5 times x, but we know that that's really just 5x. Bless you. So do we understand how I condense with the product property right here? Yes? Now let's look at the right side. The right side, there's nothing to condense. It's just simply log base 4 of 60. So we're of course going to raise both sides. This whole thing is going to become the power of base 4. And this whole thing over here is going to become the power of base 4. And yes, 4 to the log base 4 eliminate, 4 to the log base 4 eliminate. So we have 5x equals 60. So if we divide both sides by 5, our final answer is x equals 12. Ta-da! Now, whenever we get an answer, we should just double check, take a moment, double check that, make sure that we don't end up with log of something negative. Because if you have log of something negative, we know it ends up being an error. It ends up not working. So it'd be an extraneous solution. So like if this answer would have been x equals negative 12, I would have said no solution. Because this cannot be a negative 12. You cannot do the log of any negative number. Anyway, let's move on. Number 15. What property are we going to use here? Quotient, right? Quotient property. Again, here are the properties. And since we have a minus sign, the only one with the minus sign is the quotient property, which means we're going to condense it. We're going to make it one single log base b of m divided by n. Okay, so we're going to take these two separate identical logs, put them as one log. We're going to put m divided by n. So that's what we're doing on number 15. We're going to take that log base 5 and that log base 5 and write it as one single log base 5. And of course, with that quotient property, put the parentheses here, and it's always going to be the first one divided by the second one. So it's going to be y over 8. Thank you. And we have equals log base 5 of 1. And of course, we're going to raise both sides of this equation to become powers of base 5. That way this eliminates, and this also eliminates. You have a new equation that reads y divided by 8 equals 1. Simply solve this like any other equation, multiply by 8 to get rid of the fraction. You end up with y equals 8. We are done. Moving on, number 17. 17. Power property? Absolutely. We have two to do. We have product property and power property, right? So remember this. To do I know you guys are seeing the plus sign and thinking, oh, the power property is what I want to use, or the product property is what I want to use. But you can't really condense unless you have log plus log. And right here we have log plus 2 times log. So we don't want this 2 times. And that means that we could use the power property to condense, to get rid of this 2 times first. So let's take that multiplication of 2, and with the power property, we're going to be able to rewrite it. We're going to be able to condense it by putting the 2 up here on the 5. So let's begin with that. Let me just rewrite everything. Log base 9 of 4 plus log base 9 of 5 squared. I might as well write that as what? 25. That's right. 5 squared is 25. And now, since I have log base 9 here and log base 9 there, I could condense it with the product property and say log base 9 of what? Of what times what? 4 times 25. What is 4 times 25? 100. All right. So we have log base 9 of 100 equals log base 9 of W. And now we could get rid of that log base 9 by raising both sides of this equation to become powers of base 9. And 9 to the log base 9 eliminates. We have 100. 9 to the log base 9 eliminates. We have W. And guess what? We're done. 100 equals W. W equals 100. Number 19. What properties could we use? See, the thing is this. You see log base 10, you want to raise it to become power of base 10 so it could eliminate, but the problem is you have 2 of them, so we need to condense it, yeah? This one's interesting. It's very entertaining because we're going to use the product. There's a plus sign. We're going to use the product one to condense log base 10 and this log base 10 and write them as a single log base 10, which is technically common log. And we know we're going to have m times n in there, but what do I put in there and what's being multiplied? What's being multiplied? X times 3x minus 5. So I really have x times 3x minus 5. So I need to simplify that. Let's distribute x times 3x, 3x squared, x times negative 5, negative 5x. Now that's still inside the parentheses, inside the common log base 10. Anyhow, I've condensed the left side. The right side, it's log base 10 also. It's also a common log of 2. So now that I have log base 10 of something equals log base 10 of something else, I could raise both sides to become powers of base 10. So I put 10 right here, 10 right there. 10 to the power of log base 10 eliminates. I have a 3x squared minus 5 that comes down. And I have 10 to the log base 10, which eliminates. And I'll have a 2 right here. Now we need to solve this equation. This is a quadratic equation. I forgot the x on the 5. Thanks for telling me, guys. All right. So I have 3x squared minus 5x equals 2. Whenever I have a quadratic equation, I set it equal to 0. So let me rewrite this whole thing over here on the side. We have 3x squared minus 5x minus 2 equals 0. And we could solve this quadratic equation using the quadratic formula. X equals negative b plus or minus square root of b squared minus 4c divided by 2a. Or we could try to factor, split, and solve using that multi-step process because the a value is 3 and not 1. So do you guys want to try to factor, split, and solve, or do you guys want to use a quadratic formula? Even factoring is not that easy. It takes those steps, right? See if we remember those steps. Let's zoom in. So step 1 is to multiply a times c. A is 3, c is negative 2. So when I multiply those, I get negative 6. Step 2 is to think of the multiples of negative 6 that combine together to give you the b value negative 5. Bless you. The only way, was that a cough? Unbless you. I'm sorry. No, you're always blessed. Okay. Question? Restroom, yes. Okay. Bless you, whoever's sneezing. And cover your mouth. Coronavirus is out. All right.
Into your elbow, please.
Into your elbow. Where am I? Step 2. I need to think of the multiples of negative 6. Negative 1 times 6 or negative 2 times 3. Those are the only possible ways of getting negative 6 besides changing signs. So which pair of numbers, if I combine, gives me a negative 5? The negative 1 and the 6, when I combine those, it gives me a positive 5, but we know that that's a negative 5. So we have the right numbers. We just have the wrong signs. So let's switch them to a positive 1 times a negative 6. So those are the correct pair of numbers that I want on step 2. And I hope we remember step 3 is where we jump to the answer format, and we had a AX right here and an AX right there. A is 3 with an X. So let's write down those 3X and 3X. And we take that number, the pair of numbers from step 2, and write them right in here. And this, of course, is all previous knowledge. It's all from semester 1. This multi-step factoring method when your A value is not 1. And your fourth, we call it a magical step because you take the 3x minus 1 and divide it by whatever you can, which you cannot divide by anything, so you leave it 3x plus 1. And the other one, we could actually divide by 3, and it'll become x minus 2. Now, all we've done is change this quadratic trinomial to look like a binomial times a binomial. So why would we do that? Because it's still an equation that's equal to 0. But if I put equals 0 right there, I could now solve using the zero product property. What is the zero product property? It says that if you have something times something and it equals 0, then the first something, 3x plus 1, could be equal to 0, and or the second something could also be equal to 0. And if you solve both of them, you'll get x equals negative 1/3. That's one possible answer. And x equals positive 2. That's another possible answer. Now, why do I say possible answers? Because what? Because you can't have a negative inside a logarithm. Good. Now, just because it's negative doesn't mean that that's not an answer. Because if I plug it in and it, for some reason when I do the math it ends up being positive, I'm good. But when I do plug in a negative 1/3 right here, or even over here, negative 1/3 right there, you're going to have log of a negative value. You can't do that. So that means that the x equals negative 1/3 is an extraneous solution. So do not include that in your answer. If you did include it, I'd have to knock off 5 points, or 0.5. I'd have to give you half credit, if you know what I mean. So the only answer that you should write is x equals 2. Let's move on to 21. Again, product property. We have that plus sign right there in between the two. We have the same identical log base 3 and log base 3. By the way, guys, if you don't have the identical log, you can't condense or expand. You can't use the properties. It has to be the same identical log base, whatever you have. So because I have the identical log base 3, I could write them as one single log base 3 of d times 3. What's d times 3? 3d, which is definitely more expensive than the regular movie. I'm losing it. I'm sorry. And on the right side, we have a 3 right there. How do we get rid of the log base 3? Make it a power of base 3. So 3 to the log base 3, eliminate. We have 3d equals what? 3 to the third, 27. 3 to the third power is 27. Thank you very much. Again, we raise them to become powers of the base of our choice. So this is not 3 times 3, it's 3 to the third, which is 3 times 3 times 3, which is 27. Which means that our final answer will be d equals 9. I hope you guys, if you tried it and checked your answer and you actually multiplied it, that would mess it up. So please understand that you're raising it to become the powers of base 3, so you get 3 to the third. Jumping to 23. Where's 23? Down here. What two properties will I use on 23? Quotient? Power and product, right? So let's go with power first, because the only way you could do product property is if you have log base 2 plus log base 2. And we don't have that. We have log base 2 plus 2 times log base 2. So that multiplication of 2 is messing us up right now. Let's move this up to become the power of 5. So now I'll have log base 2 of r plus log base 2 of, might as well change it, 5 squared is 25. Now that I have that log base 2 and that log base 2, I could condense it to a single log base 2 of r times 25, which is 25r. And of course, it's equal to 0. So what? How do I get rid of log base 2? Raise it to become the power of base what? 2. And what you do to one side, you must do to the other. So yes, 2 to the log base 2 eliminates. You have 25r that comes back down equals 2 to the 0, which is 1. Final step, divide by 25, which means your final answer is r equals 1 divided by 25. Ta-da. Easy peasy. 25. The last one on this worksheet, right? On the odds. What property am I going to use here? Quotient. Why quotient? Because we have a subtraction. And we have the same identical log base 4 here and log base 4 there, separated with the subtraction sign. So we're going to be able to condense it to that one single log base 4 of something divided by something. So we have this n plus 1. The first one always is a numerator. N plus 1 divided by n minus 2. The second one's always the denominator. So we have log base 4 of that fraction equals 1. So we want to get rid of the log base 4. So I'm going to raise both sides of this equation to become powers of base 4. This will eliminate. I will have the nice beautiful n plus 1 over n minus 2 equals 4 to the 1 is simply 4. Now people freak out right here for some reason. They forget their algebra 1 skills. Anytime you have a fraction and you want to get rid of the fraction, all you have to do is multiply by the denominator, right? So if you had a 1/5, you want to get rid of the 1/5, multiply everything by 5. If you have a 2/3, you want to get rid of the 2/3, multiply everything by 3. Right here we have this fraction that says n plus 1 divided by n minus 2. So we're going to multiply by the binomial n minus 2. And what you do to one side, you must do to the other. And of course, this will eliminate with that. N minus 2 divided by n minus 2 cancels out. So we have n plus 1 equals 4 times n is 4n. 4 times negative 2 is negative 8. And now you can just solve this guy by moving the n's to one side. You know what? Let me move this n to the right. So that way it'll keep it positive. We'll have 1 equals 3n minus 8. And let me move the negative 8 over to the other side by doing the opposite, plus 8. So I now have 9 equals 3n, and divide by 3, n equals 3. Done. And we are done with the odd ones. Good luck. Try to do the rest. If you haven't done so already, do the even ones, please. The answers are in the back. Check your answers. We're going to have a quiz this week at some point, and the majority of it is going to be these types of solving using the properties that we've learned.